Hello friends, I am Dr. Mayank Varun, Assistant Professor in Botany from Hislop College, Nagpur. The title of my presentation is Phytoremediation Potential of Cassia occidentalis grown in lead contaminated soil. Rapid industrialization, agricultural activity, urbanization, and various anthropogenic activity over the last few decades have resulted in the accumulation of various kinds of pollutants in the environment, which leads to different kinds of pollution like noise pollution, soil pollution, water pollution, and air pollution. Among different kinds of pollution, soil pollution is of great concern. Soil is contaminated by organic and inorganic contaminant. Inorganic contaminant particularly includes heavy metal pollution, which includes various uh, metals like arsenic, cadmium, chrome, lead, and mercury. Among different heavy metals, lead is of great concern. Lead is listed on the number 2 identified by the ASTDR 2019 in substance priority list. The various sources of lead pollution in our biospheres includes refineries, industrial waste, military operation, landfill runoff, agriculture chemicals, smelter, etc. Accumulation of lead in the living organism, particularly in animals and human beings, leads to various toxicity disorder, neurological damage, liver and kidney damage. It causes various cardiovascular problems, and it can cause mutation as well as cancer too. Why the lead is a matter of concern? Lead is not degraded, hence it persists in the environment for a longer period of time. It is genotoxic, and it has a tendency to accumulate in the living organism, and it is toxic even at a very low concentration. Lead from the various sources get accumulated in the different contaminant in different compartment of the biosphere like water, soil, and sediments. Once it accumulated in the soil, it is very difficult to clean from that particular soil, and hence that soil which contaminated with the lead is of great concern, and how to clean up that particular soil is a very serious question. This particular chart shows the lead contaminated soils identified throughout the world. Now, various conventional technologies are available to remove the heavy metal from these contaminated soil, which include physical method like excavation, landfill, chemical method, thermal method, and electrokinetics. But all these conventional technologies are time consuming, labor expensive, they are costly, they are not environment friendly, and they further pollute our environment. The high cost of existing technology leads to the search of new technology, and scientists came up with a new idea which is known as phytoremediation. Now, what is phytoremediation? Phytoremediation is a new recent technique which developed over the last few decades, which includes the use of plant which are able to accumulate organic and inorganic contaminant from the contaminated area, leaving the soil remediate from that particular contaminant. There are various advantages associated with this technique. It is low cost technique, it is eco-friendly and environment friendly, it is aesthetically pleasing. Along with that, it remediates the soil simultaneously. It is uh, non-noisy, and it do not require expensive equipment. Till now, more than 450 plants have been identified as a phytoremediator plant. In our study, we are taking a plant, a test plant, which is known as Cassia occidentalis. And why we have chosen this plant to identify the phytoremediation potential of this Cassia occidentalis? The reason for selection is it is a wild native weed species, and wild native species have a resistance capacity. It is hardy, tolerant. It shows a excellent drought and salinity tolerance, and it requires very less care to grow this particular plant. Further, it cannot be used as a fodder. Cannot be used as a fodder for the living organism. Now, the methodology and experimental setup for this experiment we have made is we conducted a greenhouse study. First of all, we taken earthen pots of earthen pot 5 kg earthen pots which contain which was filled with a 5 kg uncontaminated garden soils. Then seeds of Cassia accidentalis was collected from the uncontaminated soils, and they were first allowed to germinate in a germination tray. After germination, the seedlings were transplanted to pots containing 5 kg soil. Single plants per pot was maintained. The seedlings were allowed to germinate for 3-4 weeks, after which the lead in the form of lead nitrate was added in different concentration like 25, 50, 100, 200, 250 milligram per kg as a treatment in their respective pots. The whole experiment was conducted in a greenhouse, and the pots were kept in a random block design. The whole experiment was then run for a period of 3 months, and any symptom of metal toxicity exhibited by the plant were visually noted. At each sampling date, that is 30, 60, 90 day after treatment, plants were harvested and divided into root shoot and taken for metal analysis by AAS. Plants' growth parameters like root length, shoot length, biomass, and physiological parameters like total chlorophyll and proline were also determined. Now comes to the results of the experimental study. First, we will take a look at the lead uptake and accumulation in Cassia accidentalis. The table shown the accumulation trend of cassia in the plant plant at all the testing sampling dates. Maximum uptake of lead was observed at the highest dose. Lead accumulation was found to be more in root, 5 to 10 times higher in root as compared to the shoot, and we can say that lead was preferentially accumulated in the root. Throughout the treatment, a steady increase in the lead uptake and accumulation was observed for all the plant. Further, we also observed that lead was able to tolerate the lead concentration up to 250 milligram per kg without showing any toxicity symptoms, which confirms the ability of this plant to establish and grow well in the lead contaminated soils. Chlorophyll is an important parameter used by the scientist for observe or study the growth of the plant. Lead and other heavy metal are reported to inhibit the chlorophyll biosynthesis in the plant. In our study, we seen that increase in the lead concentration decreases the chlorophyll A, chlorophyll B, as well as total chlorophyll in leaves with the increasing metal concentration up to 60 days after treatment in all treatment. However, at 90 day after treatment, chlorophyll content in terms of chlorophyll A, B, and total chlorophyll were more or less comparable to the control, which shows the adaptability of this plant. The next parameter which used is proline. Proline is regarded as a stress indicator in the plant, and it has been observed uh, in many studies. uh, Accumulation of proline in plants is considered as an important stress indicator. Further, proline plays an important role in osmoregulation, enzyme protection, stabilization of machinery of protein synthesis, regulation of systolic acidity, and scavenging of reactive oxidant species. Our study shows that all the treatments show higher level of protein accumulation in comparison to the control. Maximum accumulation of prolines was found in the highest lead concentration treatment, which is 250 milligram per kg. Application of lead in soil appear to increase the proline value up to 25 to 26 times as compared to the control, which indicates that increase in proline content is related to increase in metal stress. Plant growth parameter like root length, shoot length, and biomass was also observed, and it is presented in the following table and picture. We observed that addition of lead in soil inhibited the growth in terms of root length, shoot length, biomass in the plant. The highest value of root length, shoot length, and biomass at all the testing days was observed in the low metal treatment. Low metal treatment. So, conclusion of the present study is that Cassia occidentalis, which is taken under the present study, show a very good potential for lead bioaccumulation and also maintain its growth and physiology. Given the good tolerance, fast growth, high accumulation, and its worldwide distribution, we propose that Cassia occidentalis is a good potential weed to remediate moderately lead contaminated soil. However, it should still be tested in the field under metal contaminated condition. Thank you.